Hello. For this example, we again are going to try to write a linear model. We're going to try to use that linear model and to even decide if the linear model is correct. So we are going way back to 2010, and these are real numbers, and they're very sobering numbers. And yeah, we'll talk about that at the end as well. So in 2010, PA had 629 opioid overdose deaths. Over the next several years, the number of opioid overdose deaths increased by about 116 deaths each year. So as I read through this, I see that 2010 and the 629, this is my start. So my starting number of deaths is going to be the B value in that equation. And then we have this increased and 116 deaths per year. And so this is the rate of change. Which we know in the formula is M. So we're told to write an equation, and it's to estimate the number of deaths here in Pennsylvania since 2010. And so filling in the values we've identified, my equation is y equals 116x plus 629. So that's communicating that it started at 629 and increased, which is why I used positive 116, by that many deaths each year. It asked me to use my equation to estimate the number of opioid overdose deaths in 2012. So we noted at the beginning that 2010 was our start. And so if I take 2012 minus 2010, I find that this is 2 years later. And in my formula, since the deaths were recorded per year, year is my x value because it is on the bottom of that. My slope or rate of change is really deaths per year. And so that is telling me that y is always on the top, so deaths is a y value and years is an x value. That means that I'm going to put this into the formula where the x is. So y equals 116 times 2 plus 629. I go to my calculator and do that math on my calculator, and so literally just 116 times 2 plus 629, and I get y equals 861 deaths. And because this is historical, the actual number was 827, which is slightly lower than our prediction, but in the same neighborhood. Next, it asks us, what year does your equation predict that the number of deaths would be greater than 1,000? So since this is deaths, this is a y value. And so in my equation, I'm replacing the y with 1,000. And I am solving out for the x. And so I do have to do a couple steps of algebra to figure this out. My first step of algebra is to undo the addition. So I'm going to subtract 629 from both sides. And so in doing that, on the left-hand side, I have 371. And I have 116x is remaining on the right-hand side. So to finish, I'm going to divide both sides by 116. So the 116s cancel on the right-hand side, so that's just x. And on the left-hand side, I go to my calculator, so 371 divided by 116, and that gave me 3.19. So this is years. So this would be 3.19 years after 2010. So I can add these. So I can take 2010 plus 3.19. And so that would give me 2013.19. Now, there are two ways that are acceptable to round. So when? Well, the nearest year would be 2013. But because we have this decimal here, we can actually also understand this as after 2013, because in 2013 it didn't exactly happen. And so because we could interpret that as after 2013, we could also answer this in 2014. Again, these are historical dates, so we can look them up. And so in 2013, there were slightly less than 1,000 deaths that year. And then in 2014, there were nearly 100 more than 1,000 deaths that year. And so again, our prediction, whereas not exact, is actually a very good prediction from based on what had happened in 2010, 2011. This is a good prediction that 2013, 14, these numbers are going to be very close to 1,000 deaths those years. Now, this one I think you can do on your own. So I would strongly encourage you to pause your video and try it. And then unpause your video and I will walk you through it as well. But I really want you to pause and try the next bullet point. So the way that I did it is the year 2016, I subtracted out our starting year, 2010, and that was year 6, and that 6 is an x value. So in my formula, y equals 116 times 6 plus 629. Went to my calculator, put that in, and I got y equals 1,325 deaths. And so when I look at the actual number for 2016 was significantly higher. And this, for our first time here, 2016, this number that we predicted is not a good prediction at all. We're off by like 900 some deaths, which is a huge discrepancy, and something has gone on. So based on the fact that in 2016, our prediction does not match reality at all, we are asked, do you think your equation would be good at predicting the deaths in PA for 2020? And my answer here is no. And the reason why I would say no is because from the math I just did, by the year 2016, actual deaths no longer matched the linear trend. This comes back to things that we talked about several weeks ago. So several weeks ago, you watched an introductory video on turtles, and there were different islands, and the turtles populated those islands following either a linear, exponential, or quadratic model. And in that video, it talked about that exponential always outgrows or always outpaces linear. And so if we would look at our data on a graph, and so here we have our years, our x value, and here we have our deaths, our y value. And from our scenario, we had them going up by 116 each year. And so our deaths went like this, up every year. And then I'll put this in red. In reality, our equation was a real good predictor. Our data values were right along here for the first little bit. And then we have this going on, and our data values curved, and our data values following a curve like this shows that it is actually exponential. When we look at just the beginning, both the exponential curve and the linear curve are very close together. And so here in the first couple years past 2010, we do see a linear trend, but unfortunately, that did not continue. And the reason why we currently have an opioid crisis on our hands is because of the exponential growth, which goes up steeper and steeper. And then the whole opioid overdoses kind of went under the radar as we dealt with COVID for a couple of years. But as numbers are coming up as we emerge from COVID, the deaths are just horrifically high. And so we really do have just a crisis on our hands as this has been growing not linear, not by the same amount each year, but increasing each year, growing at a faster and faster rate. And so if this is something you're passionate about, there are some ways at the college that you can connect. There's been some webinars on addiction, and there's different agencies out there like Compass Mark that you can connect with. And there's definitely signs you can look for as you're working with patients and clients, and just something that you might want to consider being passionate about as you enter a career in healthcare.